Hello guys, welcome back. Today we are here to discuss about a question called Search in Rotated Sorted Array. Question number 33 from lead code. Let's jump into the question. So the question is pretty simple. Like you have already understood that okay, we need to search for an element in the array. But obviously how we will search, how many techniques we have. Very everyone knows is linear search and binary search. So you can apply this one or this one. So linear search, it's very straightforward. You will go to each and every element and you will check for that element. The time complexity is n. And binary search, it will be log n. Okay, the idea behind binary search is if the array is sorted, if you land in the middle, deciding which half the number will be. That's how your binary search works. Now, I'm assuming these two searches are familiar for you people. So make these things familiar before you solve this question. This is very simpler question, but yeah, it's kind of difficult to write the things. So let me make it simple for you people. So yes, so we need to search these two techniques we can use. The simpler way to do this particular question is use this linear search. Done. Go to each element, search whether the element is matching to the search element. If yes, okay. If not, go to the next one. That's all. But here they are saying that the array is sorted. So when the array is sorted, which technique we can use? Binary search. But here comes your main thing. It is rotated. It is rotated sorted array. So the array is sorted, but it is rotated. So we need to search in that array. And they are also mentioning that you need to write an algorithm using log and time complexity, which means we need to use binary search. So we need to modify our binary search in such a way that it will give you a result in log and time. Okay. Now let's clean this one. So as we know, this you can solve it in linear search, but the time complexity is big O of n, and they're asking us to do it in big O of log n. So obviously big O of log n is nothing but binary search. Binary search. Now let's start doing it with binary search. Let's understand how exactly this binary search works. So let's take one example. And before that, I hope everyone knows what is rotated sorted array, right? It's very simple. First thing is sorted array. So the array is sorted. Let's take one array, sorted array. 1, 2, 3, 4. This is how the sorted array looks like. Now let's assume that this is rotated by 2 times. Now the array will look like 3, 4, 1, 2. So this is what we will get as a input. This is what we will get as a input. This one we will get as input, guys. 3, 4, 1, 2. The array is rotated and sorted. Okay. The array is rotated and sorted. Now let's clean this one. Let's take one example. Right. So this we will take. Okay. Now this is the array that we need to search. And if you observe, this is a rotated sorted array. Rotated sorted array. Okay. Now target is given as 0, which means we need to search for 0 in this particular array. In this array, we need to search for value 0. Value 0. How you will do? How you will do? Very simple thing. Let's make it simpler. How your binary search works? What are the things that we have in binary search? We have left, right, and also mid. Left is initially 0, right is length minus 1. So let's take 0, 1, 2, 3, 4, 5, and 6. So left is initially 0, right is 6. Mid is, we have a formula that is left plus right by 2. This is how your traditional things are. I'm going with the same thing, guys. I'm not making any new things. I'm doing binary search itself. Okay. 0 plus 6 by 2 is 3. Okay. We got mid value as 3. This is the value. Now the value at mid is 7. We are searching for 0. Now the main point here is which side I need to search now. Obviously 7 is not matching with my target 0. Now I need to decide which side. I need to decide which side I need to go. Either left side or right side. Which side I need to go, left or right? That's what the question is. So what you will do? How you will decide? How you will decide, guys? Pause this video for a second. Think about it. Okay, I'm assuming that you have thought about this. Let me give you a brief explanation here. So, how we will decide which side I need to search is we simply search or we simply identify which part of the array is sorted, either this part or this part. Okay, which part of the array is sorted? That's what we identify, guys. That's what we identify here. Okay, if you observe, if you identify this one, I have two parts. One is left to mid. Other one is left to mid. Other one is mid to right. Which side is sorted? Now you say me 4, 5, 6, 7 sorted or 7, 0, 1, 2 sorted? Obviously, obviously everyone knows this. Like this is a very simple one. 4, 5, 6, 7 is sorted. How you will identify this is sorted? You again go and each element in increasing order or no, we don't do. Simple thing. If 4 is less than 7, if 4 is less than 7, what does this mean? This part is sorted. You can question here that how you are identifying by simply comparing these two values, how you can conclude. This is the one thing that you can ask me. How I am getting concluded, how I am concluding here is the array input array is rotated sorted array. So it is sorted. Somehow it is sorted. So if 4 less than 7, all the elements are sorted. Right. If this is sorted, we will check in this side. If not, now if you observe this one, 7 and 2, 7 less than 2, is this true? No, this is not sorted array. 7012 is not sorted part. So we will identify which side using the left part. Okay, we will go to left part. Now we will identify which side I need to search. Okay, first step is finding finding sorted part. Finding sorted part. Okay, now we know 4, 5, 6, 7 is sorted part. Now, but our target is 0. If you observe, 0 is not there on the left side. But how you will identify? Here comes the trick, guys. Once you understand this part is sorted, you can simply say the values are 4, 5, 6, 7. You can simply identify whether 0 is in this range, in the range of 4 to 7 or not. Now, how you will say 0 should be greater than 4, 0 should be less than 7. Is this true? No. Which means in this sorted part, we don't have our target. Now, go and search on the right side. We are not going to individual element, guys. We are simply using the extreme values here, 4 and 7. We are using the extreme values 4 and 7. And using those 4 and 7, we are identifying whether 0 is in this range between 4 and 7. If so, we will search here only. If not, we will search on the right side. The same point continues, guys. The same approach continues till the last one. Let me clear this one. Let's take left, right. This is mid. 7. Now first we will identify this is sorted. Yes, obviously that part is sorted, which means 4, 5, 6, 7 is the array that we will choose to choose. Now, is this target in this range? No, not there. The target is not in this range. Then what is where I need to search? I need to search on the right side. I need to search on the right side. Right. When you search on the right side, what happens? This will become your left. This is your R. This is your new calculated mid. 0, 1, 2. Same approach. 1, 0. They are not matching. When they are not matching, what you will do? Which part is sorted? 0 and 1 or 1 and 2? Obviously, 0 and 1 is sorted. 0 comma 1 is sorted one. So when 0 comma 1 is sorted, you will identify whether 0 falls into this range. 0 greater than or equal to 0, 0 less than or equal to 1. Both are true, which means this is the range I need to search for. So I will move my right side to left. So this will become my right. Okay, right equal to mid minus 1, right? Right equals to mid minus 1. As everyone know, right is equals to mid minus 1, guys. Okay, right equal to mid minus 1, which means this is your mid minus 1 is this is your R now. Left and R are pointing to 0. Left plus right minus left plus right by 2 is mid. This is your new mid. And 0 is equal to 0. Return this index. Index, let's say 0, 1, 2, 3, 4. Index has 4. Answer is 4. That's all done. This is the way we solve this question, guys. I hope this question is clear to you people. Now let's write the code. It's very simple thing. Very simple thing. First part, apply binary search. Okay, calculate mid. After that, what we need to do? Okay, find sorted part. Now check whether target falls into sorted part. If yes, if yes, if yes, search on. If yes, choose that part. Else, choose other part. Okay, this is how we do. Let's take int left equals to 0, int right equals to nums dot length minus 1. Now, as usual, while left less than or equals to right, we will apply our binary search. First thing is calculate mid, int mid equals to left plus right divided by 2. After calculating mid, simple thing, everyone knows this. You check for nums of mid is equals to target. If yes, return mid. That's all. Else if not that, what I need to do? I need to search or I need to identify which part is sorted. How I will identify? If nums of left less than or equals to nums of mid, then left. If this is true, what I can say, guys? If this is true, left part is sorted. Okay, good. If left part is sorted, what I need to do? I need to check whether the target falls into sorted part. I need to check. How I will check? If target is greater than or equals to nums of left and target is less than or equals to nums of mid. Okay. If it is in the range of left and right, target greater than left and target less than mid, then what I can say? It is in that part, which means right will move to mid minus 1. Else, go to left side. That's all. Go to right part, mid plus 1. When you are moving right left side, right will be updated. When you are moving right side, left will be updated. I'm doing the same thing. Else, if okay, if left is not sorted, left part is not sorted, right is sorted, right? Right is sorted. So when right is sorted, again same thing. Decide which side, whether you stay on the right or you should go to left. We need to decide. How? If your target is greater than or equal to nums of mid and target is less than or equal to nums of right. If your target falls into right side part, mid to right range, then search on that side, left equal to mid plus 1. Else, search on left side, right equal to mid minus 1. At the end, if you don't find the answer anywhere, what you will return? Return minus 1. That's all, guys. This is what we will do. Very simple thing. We are finding the sorted part and checking whether the target falls into that sorted part or not. If yes, we will move there. If not, we will move to the other part. See here. I am assuming finding the mid. If mid is target, I am returning the value. If not, I am identifying left side part is sorted or not. If left is sorted, I will check whether it falls into left side or not right side. If left is not sorted, if this is false, I will go to right side. Obviously, if any one of the part will be obviously sorted. So I will go to right side part. I will check the same thing again. Is it if my target falls into right side part or not? If it is falling into my right side part, obviously then search in that part. If not, search in the other part. That's all. In this way, we solve this particular question, guys. Take one example and dry run this particular code, then you'll understand it much more clearer. Okay, I hope this approach and video are clear to you people. I'm assuming that you have enjoyed the video. Let's meet in the next one. Until then, see you guys.